going to the next part of the event, so to the round table. So I'm going to welcome our speakers. I will start with our moderator, Pierre Mounier-Kuhn. Pierre is chercheur au CNRS and also affiliated to Sorbonne University and CentraleSupélec. Our second participant to the round table that you can see here, which should be, yeah, it's Baptiste Mélès, chercheur à CNRS, archive Henri-Poincaré and Université de Lorraine. And we also would like to welcome, please unmute yourselves and also show your camera, to Hansen Sue and Marc Weber from Computer History Museum, Mountain View, California. So thank you very much. And in particular, thank you very much because now it's early morning in California. So thank you very, very, very much for being here today. And our and the last participant of the round table is Moritz Feichtinger. And so please unmute yourself if you didn't. I'm seeing you in the camera. Hello. So, and he is also streaming from the US. So Moritz is a proud member of the history department of the University of Basel in Switzerland. So welcome everyone. So now I'm going to leave the lead to Pierre.
As a leader and moderator, I'm allowed to say a few words about a more general topic, which is the computing and IT heritage, of which software heritage is a major and growing part. Since the late 19th century, major museums of technology have started presenting calculating devices. This was in the perspective of the history of scientific instruments and the materializations of mathematical concepts. So this went from Pascal machines to our arithmometers and early analog computing machines. A big change was observed in the 1970s, 1980s, a bit somehow a century later, when computers, stored program computers, electronic digital machines started to enter the collections in turn. And with a few exceptions, computers no longer entered the collections of these museums as scientific instruments, but as material testimonies of the industrial civilization, of the third industrial revolution. So in a much broader perspective, scientific instruments and mathematical machines, as computers were called initially. So computers entered the collections of the major technical museum, but also specific museums were created, computer museums, collections of calculating machines and computers in the continuity, or even more specialized collections like new generations which appeared in the early 21st century. Old young people who had been young in the 1980s and who had been initiated to computing with microcomputers, who started collections entirely devoted to microcomputers and video games of the 1980s, or even of the 1970s, which for them was the most ancient, the most archaeological thing they could imagine, until they discovered that other older museums had something called mainframe computers or even mini computers, which for them were not mini but huge. So we have generations of collections which added to each other in time. So now I did a little counting on the internet. Over the world, globally, we have something like 200 computer museums. Overall, it's a very approximate statistics, but I think it gives a good idea. So in this, we have many material collections, which we all know, the Science Museum in London, the Musée des Arts et Métiers, all the computer museums, beginning with the one which is now in Mountain View, but which first visited when it was in Boston, the Nixdorf Museum in Paderborn, etc., and more specific specialized collections, museums like the NAM IP in Namur, the Nixdorf, the Bolo Museum in Lausanne, in the basement of the Polytechnicum, or the Aconite in Grenoble, Homo Calculus in Bordeaux, etc., etc. I'm not going to enumerate them all. And we have virtual museums, where all these material museums have websites, and they are visible on the internet. But there are collections which are exclusively virtual, exclusively visible on the internet. That's the case, for example, of the museum created online by the Information Processing Society of Japan. We have several virtual museums in Russia and one in Ukraine. We have perhaps one of the best example, a real masterwork of computer museum, which is entirely virtual, is the arithmometer.org, entirely devoted to this early pioneering 19th century machine, which is from all points of view, graphically, documentary, clever interaction. It's a masterwork. So I'm not the author, so I can do a free advertising in praise of the arithmometer.org website. One important thing is, from my point of view as a historian, is what is the relationship between collections, curators, repositories, and the historian. The relationships goes in both senses. The historian, as an expert, can bring many things to the collections, to the museums, as a consultant somehow. The historian can shed light on the context of production and use of the machines, the artifacts. The historians can shed light on the respective historical importance, on the relative historical importance. That's a very practical matter, because the historian is often consulted to answer the curator who sees an old machine being donated by a company or by a user, and who wonders whether this machine is historically significant. It may be very significant, like an IBM 360 of 1964, but every museum has a copy, has a unit of an IBM 360, and it's a stake because it's huge machines, it's costly to transport them, it's costly to maintain them somehow. So that's a practical role of the historian. And of course, the historian can bring his expertise to organize exhibitions, write catalogs. I have a sort of a certain personal experience in that from since in the last 30 years. And the other way around, the collection, the museums can bring a lot to the historian who has learned, who has done the effort to read machines, not only to read books and archives, but to understand what machines or what technical documents say. have a few examples. The machines or the documents, including the software, can be used as sources. One of my favorite examples is an inquiry I did on the plan calcul, on the French national policy to develop an advanced computer industry in France and in Europe. We have one of the computers developed by the plan calcul at the Musée des Arts et Métiers, and I opened the doors of the machines, and I looked at the circuits, at the electronic circuits. And I regret not to have had time to project my slide, but I took a picture of it, and all chips that was a machine from the late 1960s, so they were already integrated circuits. Almost, well, 2/3 of the chips had the logo of a logo looking like an I, the letter, inside the little design, which looked like a country or region. So I look at the map for Texas, and it was exactly, well, it was Texas Instruments. 2/3 of the microchips of the plan calcul computers were manufactured by Texas Instruments. So that gave a precise measure of the dependency or autonomy of a European sovereignty policy in digital machines at that time. If we switch to software, I have the first occurrence of a detailed plan for a computer in France. That was in 1949. And with the plan, with the architectural design of the computer, was an annex, which was a program of calculation. I don't remember what sort of calculation, but it was a program for a computer which wouldn't be built before 2 or 3 years. So it was almost an abstract program. And we have more programs, more initial instructions for these machines. I read it with a friend who is, wait.
1 minute, and then we start the round table.
Okay. It was very obvious that the most interesting things in these programs of 1949, 1950 was that they were absolutely not original. They were entirely closely inspired from von Neumann writings and the ETSAC experience in London. So we have a very good proof of a technology transfer, of a technology and concept transfer. And 10 years later, the same company developed an early mini computer, which was programmed with punch tapes. And I have a collection of punch tapes. I've also recuperated, I've saved a few parts of the machine. This is a tic-tac-toe. This is not a program to calculate ballistic missiles. It's a tic-tac-toe game. And it shows several things. It shows first that the engineers, the programmers of this company had started to master the art of computer programming. It shows that they were playing with it. It was an entertainment for engineers. It was also a sort of provocation, because one could wonder what was the sense of what was the purpose of using a 500,000 French machine to play tic-tac-toe. And finally, it was a proof that they were experts. So it was also part of the marketing of the company somehow. We are able to do anything, not just calculating, but also playing things, playing games. And that was one of the many proofs that the computer was becoming a universal machine.
Thank you. So I suggest that we have a quick introduction. So let's start with Baptiste Mélès.
I'm going to speak about some philosophical uses that can be made of a software archive. I'm trying to put it. So the question one can ask is why should software archive matter to philosophy? And the answer to this question can be found in a very specific kind of philosophy, which is a historical philosophy of science. This trend in the philosophy of science is in French called épistémologie historique, but epistemology in French means philosophy of science. It's not a theory of knowledge in general. And this was authors like Léon Brunswick, Jean Caveliès, Lotzmann for mathematics, Gaston Bachelard for physics and other sciences, and Georges Canguilhem for medicine. So there were some authors who worked about this. So it was these authors who were working about different sciences. They shared two fundamental theses. The first one was that science helps to know what thinking is. And the other one is that history of science shows how thinking may evolve. So the second thesis is quite a consequence as to the first one. So the first thesis, science helps to know what thinking is. I give a quotation of Jean Caveliès, who says, I don't care about defining mathematics.
Thank you, and apologize for all these technical difficulties. So what I propose, I'm suggesting that we continue with the presentation. So now I'm giving the word to Hansen and Marc from Computer History Museum. If you want to introduce yourselves, and thank you for the patience.
My name is Hansen Su. I'm a curator at the Computer History Museum, part of the Software History Center. I joined the museum in 2016, and Mark, I'll let you go now.
Hi, I'm Mark Weber, curatorial director of the Internet History program at the Computer History Museum. And I guess I've been with the museum since the late 2000s. I've been researching history of the web and the online world for over 25 years. And I'm very happy to be here. Thank you.
And so, Moritz, can you briefly introduce yourself? And what is your relationship with software preservation as an historian?
Yeah, well, as you said, I'm an historian and I'm currently conducting a project on the use of information technology to monitor political attitudes during the Vietnam War. And although this project involves emulation and digital forensics, I'm mainly concerned with the historiographical meaning of software. So in my case, the software is not preserved, but what we do have are the data sets as a bit stream. And the idea is to somehow critically reconstruct the software from the data sets and documentation. So what I hope to contribute to this panel and this wonderful workshop is the demand or the user perspective.
So, yes, so Baptiste, yes, so maybe you want to sum up your thoughts that you were sharing with us with your presentation.
So the first thesis is that science helps to know what thinking is. And one quotation I had of Caveliès, he says, I don't care about what are mathematics. I don't care about defining mathematics. But what is interesting to me is to know through the mathematics what is a thinking knowledge. And he says that the mathematical knowledge is central in order to know what is knowledge in general. So this is a kind of philosophical use of science to solve some philosophical questions. What is knowledge? And the second thesis was that history of science was useful to know how thinking may evolve. And I had some example, so it's a shame that you don't have it on the screen, which was of Georges Canguilhem about the way in which in medicine you had a switch from a fibular theory to cellular theory. So first you had a theory in which you had a grid like this, and then you isolate one square in each cell of the grid, and then you can take it as a cell, like in the cellular theory. So there was a continuous switch from fibular theory, in which you had a grid, to a cellular theory, in which you have cells. And so for Canguilhem, it's interesting because it shows how thinking may evolve in science. So you have assertions which you claim to be true at each step, but the question is, how do you switch from one state of science to another state of science? This kind of evolution. And the point is that in a philosophy of programming, in a philosophy of computer science in general, we have the two same things as in this kind of philosophy of science. The first thesis is that source codes show what is this kind of thinking that programming is, and programming is about the rational planning of actions in general. So not only for computers, but in general. So that's the usefulness of source codes. And the second point about history of science, so the use of history of science to philosophy, is that software archive shows how this rational planning of actions may evolve. And I had 2 points to show this. So the first thesis about source codes showing what is the rational planning of actions. I wanted to do some advertisements, and I'm not as neutral as Pierre was, because I am a co-organizer of a seminar which happens here in Lip6, where Roberto was invited 2 years ago, and Stefano Zaccheroli at the beginning of the project Software Heritage. And this seminar is about commentaries of source codes. So people come and they explain, they comment on source codes from philosophical, historical, philological, semiological, sociological, literary reading. And then we have a discussion about not only the code, but the stylistic choices, linguistic choices, the purposes, the uses, so everything which is behind and around the code. So this is the first thing that we can have a philosophical look at source codes. And then what concerns software archive, so the history of source codes, I wanted to show you an example of what can be interesting. It was the semaphore patch of Matthew Wilcox in 2008 in the Linux kernel. And it was very interesting because he deleted more than 7,000 lines, and he added only 300 lines. So he deleted a lot and he added almost nothing. And what did he delete? It was only architecture specific lines, which are about the making the semaphores more efficient for this and this architecture, for each architecture. It was in assembly language. It was very specific to each kind of processor. And that is what he deleted. And what he put instead is just one general semaphore.h and one general semaphore.c files, which worked for every kind of architecture. From a technological point of view, it was a loss because it was less efficient, but not so much less efficient. And that's the point. He says in the comment of this modification, semaphores are no longer performance critical. So a generic C implementation is better for maintainability, debuggability, and extensibility. So that's not only about computers and efficiency, but that's about purposes for programmers. So it was a loss in technical performance, very a small loss, but it was a significant gain for programmers' purposes. So this is my conclusion. Why should software archive matter to philosophy? This was a question. And the answer is because it shows what is the nature and the evolution of programming, meaning that programming is not only about computers, but it's about thinking and speaking about rational action in general.
Thank you. Thank you. Thank you. So we got our last hour of work today. So I think that it would be nice. I mean, we've seen many different presentations about different aspects of software preservation, and in particular about the aspect of collecting and archiving. And tomorrow we are going to tackle the display part. So in particular, I would like to thank Marc and Hansen to be here. I mean, we had a very nice presentation, recorded one by David Brock earlier today. So, and I was in particular, I already knew about it, but it's, I mean, what is impressive is that the variety of different strategies that you have, and that covers, you know, a lot of different possible ways of preserving software. And so I would like to ask you, as I couldn't ask David this morning, in particular, what do you find the main challenges when it comes to software preservation? What are the pros and cons of different ways of preserving it and collecting it and so on, in your personal experience? So if you can also give us a few practical examples, could be nice in your personal experience.
I can start first. I guess in my experience, I guess one of the things about collecting software is so much of our collection is focused on sort of PC software, because that's the easiest kind of software to collect. But other sort of, you know, older kinds of software, mainframe software, mini computer software, stuff that doesn't come, you know, on a floppy disk or in a package, that's always been harder to collect. Now that kind of, the older stuff is more the area of Alcaso, who is our software curator. And he has the technical knowledge to read old media, so old magnetic tapes and paper tapes and old magnetic formats that are no longer in use today. But then, you know, Marc can speak to this also, is that more recent software is also very hard to collect, in some ways almost impossible to collect, which is, you know, software has moved to the cloud or has moved to proprietary app stores. And, you know, in the case of, you know, the iPhone, for example, and we had one recent instance where we had a donor who was I think it was the CFO of the Siri company before it was acquired by Apple, give us, he offered to us an iPhone with the original Siri app on it. And we already have that model of iPhone. So we didn't want to keep the hardware, but what I did was I copied I used a tool on my computer at home to copy the actual bits of the app from the phone to my computer. And I also, you know, I played around with the app on the phone. And so there's two difficulties there. One which is once I've taken the app off of the phone, I can't run it on my computer unless I have some sort of iPhone emulator. And the only iPhone emulator that exists is actually Apple's developer tools. And that only runs the latest versions of iOS. It doesn't emulate older versions of iOS. So I can't exactly run an older version of an iPhone app that, from 10 years ago. And it comes at, in the form of like a file that just can't easily run it in a modern PC. The other problem is that even if I could run it, and when I was running it on the original iPhone that it was on, it doesn't do anything because the Siri app requires a server. It requires connection to the Siri servers that have now been turned off because after the Apple acquisition. So even though I could, navigate the app and I could click the buttons and I could navigate the interface, the app actually wasn't functional. It couldn't do anything because most of the functionality is server based, and that's true of the vast majority of mobile apps, whether it's iOS or Android today. So that really goes to show you that a lot of the sort of the modern world of software is becoming increasingly difficult or impossible to collect in a meaningful way. And so, one of the things that David talked about with video ethnography is that enables you to capture at least the usage of an app in a certain context, right? So if we could capture like the usage of if we could have captured the usage of Siri back when it was still an independent company and before the acquisition, and we could have like videotaped that, then that would have been a good record. Of course, the problem with that is we also have a 10-year rule typically where we tend not to collect things until after 10 years because it's usually only after that amount of time that we've realized something is now historically relevant. Now there are exceptions to that rule, but in general, we tend not to do video ethnographies of software that just came out, right? So we wouldn't have known like at the time that like, oh, okay, well, we might have known, but typically, at the time that Siri was still an independent company, we wouldn't have known that Apple was about to acquire it and that this would become, in the historical relevance of this thing would become enormously more important than it was at the time. Now, of course, it already was important because it has a history that goes back to SRI and that, Marc can speak about. But, that's just one of the examples of how, collecting software is becoming more and more difficult. And, which is why we have all these different other ways of trying to collect software or get at the story of software, which is where we're trying to tell the story of software or archive the history of software as much as collecting the software itself. That's the larger vision.
So I think that, so I'm very, very, very interested in your, video ethnographies, because I think that they both in a way are collecting information and displaying it. But today I would focus, because we have another session tomorrow, so today I would focus more on the archiving. So I'm thinking about asking Marc, like, so when it comes to preserve the internet, so what are the challenges? Because there are.
And this is where I actually did a presentation, it's probably 5 years ago, on how the net is eating software. So as Hansen was saying, it's increasingly hard to preserve stuff that's in the cloud. And what's really happening, the same challenges that we faced around the web and the internet 25 years ago have now sort of spread to basically all software, except for, with some exceptions. But things are now cloud-based, server-based, they're often proprietary. So it's not even a question of whether it physically could be preserved, it's whether you have the right to. When software was distributed, even shrink wrap software was particularly easy because there were lots of copies like published papers, like a book. But even, commercial enterprise software until the last 10, 20 years would be distributed in some medium that you could actually preserve. And there was a meaningful version number. And if you had it, you had it. And that's the kind of thing that, as Hansen was saying, like our colleague Al Casso can read old tapes and things like that. But today, it's not only, there's the legal aspects, physically getting access to it. And then the servers, the problem of the server is not just, something like Siri, of course, the servers are no longer operating. But even if you have permission and everything going to get the server side of modern software, that server side is more of an ecosystem than a single version. And it's depending on lots of other attached services that have different version numbers. So you really would have to recreate an entire ecosystem. Plus, if there's user involvement, and this, I remember it's 15 years ago, a colleague saying that, for social media, it's almost impossible to meaningfully preserve without the user input. So, essentially, we've gone back to an oral tradition in many ways. It's like trying to capture a conversation that only happens at a particular time and place. The video ethnography is, it was actually some of the people doing virtual worlds that I first heard about that. It's more than 10 years ago that they, in a sense, gave up. It's impossible to preserve the underlying environment in a way that you can recreate it. So the best you can do is try to video users actually interacting. So in a way, it's an admission of failure. That doesn't mean it's not extremely valuable, but it's a second choice because it really is impossible to recreate that online software environment that you would need. And again, a social media virtual worlds without users is dead. I mean, it's again like a room where you could have a conversation, but no one's talking. So it's really spreading, I think it's part of a larger trend that we're going away from very durable media toward more ephemeral ones. In a sense, clay tablets lasted even longer if they were burned in a fire because it made the clay, it fired the clay. We've gone through paper and now digital media. And, I think what's frustrating for me, and I think other people trying to preserve software, is that at the same time, it is technically, if you change the way the industry worked a little bit, you could actually preserve it very well. And as Brewster Kahle of the Internet Archive said years ago, that the good thing about digital media, the good thing about digital media is you can save everything. The bad thing about digital media is you can lose everything. So we're on that cusp where it can go either way. Right now, it seems to be more on the losing side, but the automated methods like the Internet Archive they started crawling the web in 1996 to at least get the publicly accessible part of the web. And the way some of the people here are scraping what they can from GitHub and other places, that to me seems like the most fruitful avenue is some sort of automated method, because it's very, very difficult to sort of a la carte choose pieces of software and preserve them.
Thank you. So let's go back to historians. And so you are the users of these archives in some sense. You are some of the users of these archives. So we have seen the SWAP today. So what is that you expect when archiving software, but by missing, or what what's your view on what it means to archive software as historian, as part of, you know, users of some specific users like historians?
For a historian, the source document can have many uses. There are many meanings in a document. The material support of the document gives already information regarding a piece of software. We could analyze its content, its style, as Baptiste Seminars does. We can also try to understand what the software reflects, not only of its authors, its individual authors' style, way of thinking and of programming, but also on the organization. I remember a book that was written in the 1980s called The Soul of a New Machine, which described, well, I would not call that industrial espionage, but engineers from a company called Data General who were analyzing the architecture of a computer designed by digital equipment, so their main competitor. And the book says that one of the Data General engineers said that the architecture and basic software operating system of the PDP machine reflected the very bureaucratic organization of digital equipment.
Okay, and what about Moritz?
Well, I don't know if I can generalize my experiences, but I'd like to emphasize what has already been said to a certain point. I think Ron said there can never be too much documentation, and I would strongly underline that. It is for historians more important to have a fully documented provenance of a certain piece of software or any born digital object than to have a broad coverage of the technology itself. To put it in other words, we can do more with a specific application or a specific use case than I would say with the whole technology. So that's the one thing I would like to mention. And the other thing is more a question that I would like to give back to the collecting institutions and archives. It has been said in recent years that full system emulation is kind of the golden path to software preservation. Well, I am working with digital objects from the 60s, and I encounter two difficulties here. The first one is not all parts of the original historical environment can emulate it in a meaningful way. I mean, the interfaces were very different. The peripheries are not in it. So where do you stop emulating, or how do you deal with the peripheries, which are important to understand the usage at the time? And the second thing is how do you preserve the emulators themselves? I mean, the problem piles up if you preserve software in an emulated form. And I would be very interested to hear the experts' opinions here. Thank you.
Thank you. So maybe it's time to open up the questions from the public. Anyone in the room who would like to intervene?
Maybe I could add something.
Yes, please.
What is also important for historians, maybe I'm pulling out truisms here, but is actually people. So what I would wish for from the institutions is like it has been displayed for the case of the Computer Museum, to get pictures, testimonies, any kind of sources from the people interacting with software is crucial to create any meaning out of preserved digital objects. So thank you.
Can I respond? Can I respond to that? Yeah. Yeah. So more. Yeah. So I fully agree with Moritz. That both documentation and people are extremely important to collecting around the history of software, and it's actually for that reason that I, as a software curator, I spend more time. I probably spend more time collecting documentation, physical paper documentation of software, and collecting oral histories than I do of actually collecting software. Especially since more recently, we've in our collecting plan, we've kind of put a moratorium on collecting more shrink wrap PC software, because we actually have a lot of software already, and most of what's offered is just duplicative of what we already have. So so I fully agree that these things are important, and that we put a lot of effort into collecting them, and that partly speaks to the fact that, before I was a curator here, I was myself a historian, right? I did my PhD in science and technology studies at Cornell. So I was a historian / sociologist / ethnographer. So I wear many hats as a curator. So I draw on my history of technology background, but I also sometimes draw. Before I was a historian, I was also an engineer, and before I was an engineer, I was a user and a fan. So depending on so I draw on all of these different past identities and backgrounds and experiences as a curator. So sometimes I collect something because I was a user or I was a fan, or sometimes I collect something because as an engineer working for a company, I knew certain things about this piece of software that are interesting. So I combine all those different hats. I guess also to speak to some of the earlier presentations, I come at it more from a history of technology perspective than from a history of science perspective. So it's a slightly different discipline, at least in the US. They're slightly different disciplines, and they have their own different societies. But I think that to the extent that the history of computing, at least in the US, is treated more as a history of technology story, kind of speaks more to the and Tom Haig, who's in the room and virtually will speak to this, is the fact that the computer is a universal machine, and that although it began as a calculating device, it has become many other things, right? And Tom has written about this. So those are just some of my thoughts in responding to the earlier presentations.
Thank you. So now I have Baptiste that is going to intervene, and then one question from the online attendees. I ask kindly everyone if we can be here another 5 minutes, just to, we had some technical difficulties. So if we can use 5 minutes extra of your time, we would be very happy. So please.
It was about the point that we want to know the actors, the people which are around the software. There is an issue with that, which is that we need to have their mail. And it was easy if you are interested in Gauss, Euler, or Leibniz. You have the papers, and so you have the full mail exchange of Leibniz with a lot of people. And it's very instructive for us when we study source code archive to see what is the discussion which is behind a change in the software. So there was discussion about how to put processes together and so on. And then they come to this solution which is published and so on. So it's very interesting to have the discussion which is behind. But we, as scholars, we are not very good at archiving our mails. And when we die, everything is lost. And it was not the case 50 years ago, because people wrote on paper. And so it's a huge problem, but with legal issues and so on. So it's still more difficult for software heritage. But it's a very big issue that one can have in order to study historically.
So you suggest that you make a donation to software heritage or email boxes.
Okay, so the question from the public is Ewan Cochrane, Yale librarian, easy. Emulation as a service infrastructure. So I believe Marc Weber mentioned that industry could make, paraphrasing, a few changes to make the current mostly server-based software services more preservable. Can you elaborate on that, Marc? What changes would help?
Sure. I mean, the first would be just to have very clear, preserve like the actual versions of everything necessary to make something run in a standard format of some kind, to simply know what, you need these particular servers connected with this version of whatever. And, it probably would require, and I can't imagine what it would be, but some legal requirement to keep records, perhaps a snapshot of some kind of software at a particular state. Like an example would be Siri, as Hansen brought up, that, that was an internal server within Siri when it was a private company. There was no incentive for anybody to worry about preserving the server side of that at that time. So, the problem I don't think is technical to do that. It's more the legal will or a motivation to do it. And often this works against, commercial proprietary stuff. People don't necessarily want to reveal exactly what it takes to run something at a particular time. If that could be done in retrospect, it would help. And I do think, over time, people will figure out that there's some value to that. Also, the internet, the web have no kind of archiving function built in. Vince Cerf's actually been talking some about, being able to add a historical component to the net, something that would, maybe make regular backups of certain things or certain, as I say, like version numbers. So that's what I was thinking. I don't know if that answers the question.
I see someone from the public that would like to intervene. Please come here and introduce yourself.
To complete, and I not fully agree with Marc mentioned just before.
Can you introduce yourself?
Yes, I'm Pierre Paradinas. I'm professor of computer science, specialized in embedded system, and I am also interested to set up a French museum of computer science. But it's another question. It's not the point today. My remark is following the point of Marc about it is essentially or mainly a law issue. I agree with you, there is a law issue, but I think also for some system, there is also a very, very, very complex things. If you take a payment system, for example, it implies many actors. There is smart card manufacturer, there is onset, no onset, there is an ATM machine, there is comment dire un terminal de paiement, a terminal of payment. After that, you have in the network, you have some companies that in charge to interact between the bank and between Visa and MasterCard. And for each of these relationship, it's very complex in terms of technical stuff. There is, are you sure there is secret inside because there is money, it is a transaction, and there is billion of transaction. It is a very complex system, and to have a snapshot of this and to try to put on a software heritage, it's very, very, very complex because there is a lot of actors, and it is very difficult if you succeed to discuss with Visa, for example. By the way, it is probably impossible to have in the same time the same deal with MasterCard and with every bank around the world and every smart card manufacturer, every ATM manufacturer and payment terminal inside. This is why it is very difficult also, I think, on a technical point of view.
Thank you.
And I think we're saying the same thing in slightly different. I agree that it's all of those players that interact in that transaction that make it difficult to preserve.
Yes.
Technically, definitely, but I think it's partly because there's no incentive to make that easier. For instance, if it served as prior art and was important for intellectual property, you could find technical solutions that would capture some of the more relevant information. But as it is, there's just no incentive to preserve it. Therefore, it drifts into being very difficult to preserve.
Thank you very much. So it's 6:05. So unless there is anyone else who would like to have a brief 1-minute comment, I think that we can be satisfied with our session today. And I'm looking forward to seeing all of you tomorrow. So thank you very much for your participation online and in person. And we apologize for the little inconvenience we had today. Thank you to all the speakers that talked today. So thank you very much, everyone. Thank you. And for also Lip6 and La Sorbonne for hosting us today. Thank you very much, everyone.
Thank you too.
Thank you.
I also want to thank the online coordination that made this room stay open when we dropped out. So thank you very much.
Thank you very much.
See you tomorrow.
And we can also probably name Sabrina and Luna.
Yeah.
So thank you very much for the remote help. Thank you very much. And see you tomorrow.